Good evening, Professor.
Good evening.
Yeah, good evening, sir. We are all so we are going to start the presentation today. The today topic is the demonstration of three-dimensional computer modeling. It's very good topic and very interesting, and I hope so you all will be benefited from out of this presentation. So I kindly request you to change your name with the correct name. Actually, I have seen some other names appearing in the list. So please rename your with your correct name. And the other thing is, please keep your mic muted. And so when during the question time, you are allowed to ask any question, or you can use the chat box to send your questions if you have. Okay, right. Thank you, Professor. Over to you, sir. So we'll start the
Thank you
presentation.
very much. Thank you very much. Good evening, everybody. So today I'm going to show you some of the modeling techniques. For that, I'm going to use a simple example that we used earlier. And first, can you see the sheet?
Yes,
Is
sir.
it
We can
clear?
see.
Yeah. Okay. So I'm going to use the same building that I used earlier. And I generally use the same example so that you all can keep a track of what you have done. It's a building like this, and 7.5 meters that way. It's a very simple building, but we can learn a lot from that. And that is the building, and I said we'll have some hole like that. And if you want, we can have a small piece, but I will ignore that in the modeling to save time. I'll just consider it is like this, the core, and we'll balance it. So this way, 7.5 meters each. And this way, 6 meters. 6 meters. And so basically, to balance the building, we need some wall like that. We need a wall like that. And we need a wall like that. And we'll say that this wall I have selected as 4 meters. After doing the actual calculation, if you do the proper calculation, you will find it can be slightly different. But I'll select for to demonstration purposes, I'll select 4 meters. Generally, what we do is I told you that y bar is equal to sigma iy divided by sigma I. We looked at that type of equation. From that, we can actually find what the length should be, because here you get 3 walls and another 3 here, 6, altogether 6, but each will be only 2.5 meters of length. To balance that, we need some length, so we shall say 4.6 meter, 4.5 meters. We say 4.5 meters. But you can do the calculation, but again, you can't expect it to be perfectly balanced. And all these occasions will have columns. These locations will have columns. So you will have columns like that. So what you have to do is, first we have to look at the code that we are using. So because you have to consider certain load transfer mechanism, and generally, if you have a slab like this, in Eurocode, they generally consider that the load will be transferred like this. So this is euro. But in the case of British code, this 7.56, they have given some table 316, and I will just get it on the screen first. Just one moment until I get it on the screen. I'll share the screen for a moment now. So in this code, now these are the bending moment coefficients for slabs, and then you get shear coefficients. Shear coefficient are given in the code. So that is table 350. Table 350. And you can see it's over a length of 0.75 L. You get, coefficient as this equation. Loading or supporting beam is given by beta NLX. Beta NLX. LX is the shortest. So basically, when you go with the British system, you get the load arranged over a length which is equal to 0.75 L. So this is from 0.125 L to 0.875 L. And here you get it, here you get it, here again you get the loads. So you can apply the loads like this. This is also valid. And if you want to, if you are going with Eurocode, you can use this method. And programs like MIDAS supports that method. And programs like ETEX, on SAP 2000 also you can use this method or this method. SAP 2000 you can use either of those methods. So basically you can use one of these methods. So when you are dealing with number one, number two. So basically, Rima, you can hear me, is that right? Rima?
Yes, sir.
You can hear me, right? Okay. I'm just speaking, right? Okay.
Yeah, right. Okay.
Right. Okay. So basically, now again we have to see now when we have slabs. So these 7.5 meters, these 6 meters. So generally, you might use a slab thickness of 175 millimeter. For 6 meter span, you can use something like 175 millimeter. So if you, let's say, this slab, you, due to some reason, you want 200 millimeter. This slab, so one way you can apply the loads. I'll show you SAP 2000 because I'm going to demonstrate SAP 2000. The reason to use SAP 2000 is, you will understand how it is done. But some programs use shortcut methods, like ETABS will give you a shortcut method. So it's up to you to decide whether you want to go for a shortcut method. And but when I'm demonstrating, I always use the basic method. But when you understand, when you know the basic method, you can always compare the results of the shortcut methods given in the programs. And if you are getting the same answer, no harm in using the shortcut method. But always learn the basic method so that you know the answer, exact answer you need. And if the answers are telling in the shortcut methods given in the program, then with confidence you can use the shortcut methods. But just because the shortcut method is given in a program, don't use it without checking with another program. So I'll teach only this one, but there are many shortcut methods in ETABS. You can just, for a slab panel, you can just specify the load that you are going to apply on the panel, and then the program will, while it is running, if you define it as a membrane, it will automatically break it into small elements, and then it connect it, transfer loads onto the beams properly. A lot of things will be done as a black box. But most important thing is learn what is the basic way of doing it, and then if you are getting the same answer with the more black box type method, no harm using the black box type method, because always you have to go for more sophisticated programs, right? So I have no objection. If you want, you can use ETABS. Actually, you should go for ETABS or MIDAS. Try one of those programs. You must go for those. But SAP is also very useful. I can show you one example. I'll share the screen again, but just one more before sharing. I will go for this. I'll get the file on it. I'm going to share the screen again. This is a report that I prepared for Altea building, and I can show you a model that I used, developed. Now, this type of model, you can see I have modeled the foundation, the car parks, and the building. And I show you a 3D model. So I have modeled all the different elements. And then, these called the diagrid. So all those have been modeled. And the transfer beams, a lot of things have been modeled. Can you see this particular pie cap? This is a problem that will arise unless you control the temperature. And if you want to know how to control temperature in a concrete mix, you can type MTR Jayasinghe DEF on MTR Jayasinghe DEF, Delayed Ettringite Formation. You can download that paper, and that will tell you how not to get that type of problems. And these are kind of model. And when you go for this kind of sophisticated model, sometimes you might find SAP 2000 is far better than the more dedicated program like ETABS. The reason is ETABS is not meant for this type of complicated buildings. It is meant for regular buildings. So when you try to do a complicated building like this on ETABS, you'll find that it is actually creating trouble. So basically, this is a building that I modeled in 2012, and I signed the building, certified the building. I think in January 2013. January 2013, I certified the building. Or December 2012, I certified this particular building. And today you can see it's one of it is the tallest building in Sri Lanka, but it will be shortly taken over once this address 606 comes with 77 floors and completed, then it will be the tallest. But at the moment, this is the tallest building in Sri Lanka, and it was all modeled by using SAP 2000. So basically, SAP 2000 is also very powerful general purpose software, but some of the features that you get, advanced features that you get in ETABS, you might not get in SAP 2000. So that's the only problem. Otherwise, SAP 2000 is also a very powerful program. So I'll stop share now. Right. Now you can see. But what I always propose is that you go for ETABS and MIDAS as well, because they have better features. And when you are producing reports, they have more features. Whereas SAP, you have to do most of the report generation also may not be as user friendly as the more dedicated building software. But in SAP, you can model almost anything you like, except very complicated structures. So basically, if you want to know about this temperature control in concrete, large concrete posts, just type MTR Jayasinghe DEF. MTR Jayasinghe DEF on internet, the Google search. Then you can download the paper, read the paper. It explains how to use fly ash in concrete. That's number one. It also explains how the temperature can be controlled. That is also important. And especially in large buildings, it is very important. And if you do not control temperature below 70 degrees, the result can be a cracked structure like the one I showed in that particular report. Right. So, okay. So basically, what we do is, when you're having different slab thicknesses, like here. So first I will start with one slab thickness, say 175 millimeter. So we say it's unit load 1. So what will happen if you apply unit load? So this 7.5 meters, this 6 meters. So you get something like this, something like this. So this will be 3 meters. 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 So this part will be 1.5 meters. So basically, if you look at if one load, unit load is applied on this particular slab, the magnitude of the load on this beam, let's say AB, beam AB, the load on beam AB will be, and the load on AB will be 3, magnitude of 3 kilonewtons per meter, and here also 3, and this length will be 3 meters. So what you do is you will define a unit load. The reason is due to dead load, you get 0.175 into 25, because in Eurocode, the density of concrete is considered as 25 kilonewtons per meter squared. Then you might get a live superimposed dead load due to finishers. So under that finishers, you might allow something like 0.75 kilonewtons per meter squared. Now, what do you mean? What is the meaning of 75 kilonewtons per meter squared? And that will be sufficient to have something like a bed of 20 millimeters, and then a tile layer of about 8 millimeters. And that will be 0.75 is adequate for that kind of finishes, where you have a bed of mortar plus. So bed of mortar will be something, density will be 20 kilonewtons per meter cube. And here the density will be, tile density will be about 25 kilonewtons per meter. So based on these thicknesses, you can see, when you use something like this will come to about 5.5, 20, 25. So this will come to about 0.4, and this will come to something if you less than 0.4. So addition, it's reasonable to go for a value like 0.7. But if you think the finishers may be more, then it's better to go for 1 kilonewton per meter square. So finishers can be 0.75 or 1. And then partitions, if it's lightweight partitions, you can allow 1 kilonewton per meter squared. But otherwise, if you are going to get some partitions, then better to apply it as a point load on the, say if you have a partition wall here, better to apply it as a point load on the beam. Point load on the beam. Apply it as a point load on the beam. So that's very important. So you can, if you anticipate a partition wall, it's a masonry wall, it's heavy, go for it. But on the other hand, these days it's very useful to go with lightweight partitions. So many lightweight materials are now manufactured in Sri Lanka. You get lightweight blocks, aerated autoclave blocks, AAC blocks. With the, if you want to get more information, this company is owned by Access Engineering, but Professor Andit Dissanayake also has some 80, 98, 95. If you want any information about AAC blocks, you can contact Professor Andit Dissanayake and get the information, or else you can get the information from another engineer, Engineer Nalin Pathirana, and his number is 07729900410. And both these materials have, so this material has a density of about 700 kilograms per meter cubed, which means it's lighter than water. So you'll see that, when you make an allowance of allowance like 1 kilonewton per meter squared or 1.5 kilonewtons per meter squared, these you don't have to worry about the location of the partitions. You can have the lightweight partitions anyway you like it. Then we also have another panel that can be made to 75, 100, 120, 150, and even 200. That is too much for partitions. So basically, those panels will come in 0.6 meters by 2.4 meters, and you connect these panels. Then sometimes you put a panel this way also, depending on the flow-to-flow height. Lock all these, and these also would have a density of 700 kilograms per meter cube. But if you want to go for something like load bearing type construction, you will go for something like 800 to 850 kilograms per meter. So you can use those ones. Then that is actually manufactured by again a mechanical engineer having his own factory at Jaala, and his Niranjan friend.
ඇයි ඔය ඔතන පොත්‍රාක්කේ උඩ තියලා තියෙන්නේ
So his number is not 777 689 787. So you can get information from him. So there's a number. Or else there's another person who is manufacturing these lightweight systems, and it's called Precon Marketing. Is Mr. Sisira. He also can come up with very good solutions.
SISIRA.
And his telephone number is not 777 687 321. Now you'll ask why I have given all this context, because now we are in a very critical situation because cement is expensive. Cement has gone up to about 1,900 rupees per bag. At sand, if you are getting good sand, then the cube can cost something like 16,000 rupees to 20,000 rupees, close to that range. Then steel has gone up in price, so that it's about 300,000 rupees today per ton. So you can see all these materials are going up. So it's up to us to come up with good solutions and lighter solutions and so on. So lightweight panels can be very useful because lightweight panels will allow us to reduce the weight of the building. And when the weight of the building is reduced, then the foundation cost can be reduced. The transfer plate costs can be reduced. Even the beam and slab reinforcement can be reduced. So you can see with the supply chain problems that are there at present, and also the war, there are so many factors. Basically, we are getting a lot of steel, the billets from the Eastern Bloc countries. Like we used to import from Ukraine, Czechoslovakia, all those countries. So again, you can see there can be supply chain disruptions. So because of that reason, it has come to a level that we have to do many things in our own country by using our own resources. So basically, anything manufactured in Sri Lanka is very useful. And this one is EPS based, expanded polystyrene based, and density is reduced by using expanded polystyrene. So if you look at the density of mortar as 21 kilonewtons per meter cubed, and if you want to get a density of 7 kilonewton per meter cubed, then basically your panel will have only 33% mortar, 67% EPS, expanded polystyrene. So that's how it goes. So basically this is 1/3. So that means 1/3 is mortar, rest is air, but air, we cannot induce air into the panel easily. So we use already used Regiform that we crush back to the beads, and then we use them to manufacture these panels. So these are real recycled products. So the use of recycled products are also promoted these days because the amount of energy that we need to create the building material will be lower when we go with recycled products. So we like to use recycled products as well. So basically, when you are doing modeling, Now you have to actually get all these things sorted out first. What are you going to, how are you going to do the partitions, whether they're lightweight material or heavyweight material. If they are heavyweight material, then you have to apply the loads on the beams as concentrated loads. So now what we do is we have all these loads. So once you have a unit load, the effect of unit load, as I have drawn here, when you have the effect of unit load as I have drawn here, then the effect of the dead loads will be self-weight multiplied by unit load plus finishes multiplied by unit load. The finishes as a magnitude of 1.5 kilonewtons per meter square, so we multiplied by 5. Otherwise, it's 0.75, we multiplied by 0.7 plus the partitions multiplied by unit load plus services multiplied by unit load. So sometimes we hang the services from the ceiling when we have, sorry, from the soffit of the slab when we have a ceiling. So basically there are so many combinations. So basically when you know the unit load, you can create the dead load, then the live load will be, if the live load is 4 kilonewtons, 4 multiplied by unit load. So once you define dead load and live load, that is the fixed load and the variable load, then you might have a load combination, which is like something like 1.35 times GK plus 1.5 times live load, that is QK. But on the other hand, we might have 1.35 times GK plus 1.5 times QK plus 0.5 times 1.5 times WK. You might have a load combination like that, because in Eurocode, we have to think about the load combinations like this. What it says is you have vertical loads, and those can be dead loads, live loads, and then you have lateral loads. The lateral loads, those can be wind load, earthquake loads, and so on. Then in Eurocode, they say dominant, variable, and secondary variable. Dominant variable and secondary variable. So you might have a load combination like 1.35 times dead load plus 1.5 times live load plus 0.5 times wind load. You can also have a combination like 1.35 times dead load plus 0.7 times 1.5 times live load plus 1.5 times here, 1.5 times wind load, 1.5 times wind load. So the combinations that you create are slightly different to the combinations that you create in BS8110. BS8110, you might have a combination like 1.4 times dead load plus 1.6 times live load plus, sorry, that's one combination. Then it says 1.2 times dead load plus 1.2 times live load plus 1.2 times wind load. But in the Eurocode, it's other way around. And when you are having wind load will carry 1.5, but the live load will be multiplied by a factor of 0.7. Because what it says is you can't have the maximum dead load, maximum live load, maximum wind load at one time. So one has to reduce. So in this case, we have the maximum dead load, maximum live load, part of the wind load. This one we have dead load, part of the live load, full wind load. So we'll get combinations like that, different combinations. Whereas in the British code, it was fairly simple. Either you have 1.4 dead load plus 1.6 live load, or 1.2 live wind load, live load, dead load. So it's different. So Eurocode, you have to learn this art of creating the load combinations where we go for various combinations. So one of the combinations will be the overturning case. Overturning case means you have the dead load, and you have the wind load, and you get 1.5 times wind load. Dead load you might not have any factor because it's a favorable. So this will give maximum tension here on this side, and if you want maximum compression, then you had a 1.5 times dead load and all this 1.5 times wind load. And then you find there's no point in trying this because you are going to have another combination which says 1.5 times dead load, 0.7 times 1.5 times live load, and 1.5 times. So you can see this is more rigorous than this one. And this will result in maximum compression here. So you have to look at it in a logical way, try and understand. Our effort is to create the maximum load effect. So we have to arrange the combinations that way. But this all can be done by defining a unit load on the slab. Unit load on the slab, right? Unit load on the slab. Trima, is that clear?
Yes, sir. It's very well clear, sir.
Yeah, very clear. Okay. So basically, when you get this sorted out, on one side you have to sort out the loads, on the other side you have to think about the combinations, and then you have to think about the slab thickness. If you have two different slab thicknesses, then say this is unit load 1 and this is unit load 2. Why? Unless you use two different unit loads, you cannot define the self weight of the slab separately. So because of that reason, you use two unit loads, two separate unit loads where the slab thicknesses are different. So that's the other thing you have to get into your mind. So once you sort all these things out carefully, then modeling on SAP 2000 is also very easy. But on the other hand, when you go with a program like ETABS, even when you are not organized to this extent, sometimes the program might help you to get things done. So it's all up to you. And sometimes you'll find the buildings are so complicated, it's better to go ahead with the general purpose packages. On the other hand, sometimes you might find that it's okay to use the sophisticated computer programs that will allow you to do many things easily. So it's all up to you. Right, so I have got the basic things sorted out. Now what I do is I will get the program going. So for that, I will first open the program. Right. Now I'm going to share the screen again. Can you see the screen?
Yes, we can see, sir.
Sima, how about it?
Yeah, we can see. But your voice is not clear, sir. Some disturbances are coming.
Sima, can you see the screen?
We can see this.
2003?
Yeah, we can see the screen, but your
Right.
voice is not clear, sir. Some disturbances are coming.
In fact, first you have to actually already. How about now? Now how about the
Yes.
is it?
Still same, sir.
AC working behind me. I'll turn this. Just 1 moment. No, turn it off. How is it now?
Now
Sima?
it seems it's okay, sir.
Okay, sir. Okay.
So you are muted.
Yeah. Can you hear me properly now? I think it was an internet problem.
Ah, right. Now it's okay, sir.
Now can you hear me? Now it's better.
Still the disturbances are coming, sir.
Is it? It's an internet problem. Can you see the screen now? Or no?
Yes.
Internet is unstable. Internet is
Yeah,
unstable.
we can see the screen, sir.
Today I'm not at home, so I'm using a Bell 4G connection. So it may be. Okay, can you hear me now?
Yes, sir. Now it's okay.
Now it's okay.
Right. So basically, we have to start as a new model, and I will go with the 3D frame. And I will have one story first sorted out. And number of bays is 4. Violation was 4. Story height, shall I use 4 meters? It's generally 3.6 meters. Okay, I'll use 3.6 meters. Generally, we try to keep it around 3.6, 3.7 value. And X direction, we have 7.5. So you get a structure like this. And I will go through all the whole process for the benefit of anybody who is a beginner, but Prima, are you connected now?
It's not
I
clear.
was
You are
disconnected for a moment.
yeah, sir. You are disconnected, sir. We didn't hear you last 1 or 2 minutes.
Is it?
Yeah.
Yeah, that's right. So I was disconnected. I'm trying to connect again. How is it now?
Now we can see the screen.
Prima, can you see the screen?
Yeah, we can see the screen, but
Yeah,
your
screen, but
your
voice is not clear.
yeah, voice is not clear. It's disturbing.
I will just one more. I know the reason. Stop share. Because I have this video on. Ashage. Is it clear now?
Yeah, voice is clear now, sir.
Ah, right. Because I was having the camera on.
Ah, right.
When we have the camera on, it sometimes the strength is not enough. Internet strength is not enough.
Right.
That
Right.
was the
Now it's
problem. Right.
now
Okay.
it's clear, sir. Now
Now
it's
it's
okay.
clear. Right. Okay.
Yeah.
Okay.
Yeah.
Right. Thank you. Yes. Okay. So basically, we are defining the material. Mm, So basically, we'll add a copy of the material and we'll go for advanced material. And so we'll define it as concrete. Now these days, now when you are doing a tall building or something, better to go for something like 40 megapascal concrete. You might ask, why? What is the reason for using 40 megapascal? What you have to see is, now our construction industry has advanced a lot. And we have very good admixture manufacturers in Sri Lanka. Right? So if you have good good people, you can actually create very sophisticated uh, admixtures. And we have so many ready-mix suppliers. So when you consider all those things, getting 40 megapascal concrete is not a difficult task. And if you look at the codes, the Euro codes allow you to use anything like 50, 60, 70, 80, 90 megapascal concrete. And what is the difference between a 70 megapascal concrete and a 40 megapascal concrete? What is the main difference? You might say, no, it needs a little bit of cement more, but that is not the main difference. The main difference is the 70 megapascal concrete has very low water content. The water content is like 120 to 130 kilograms per meter cubed. Whereas the 40 megapascal concrete, you might have a water content of around 190 to 200 kilograms of water per meter. So you can see when you go for high strength concrete, the main difference comes in the admixture type. You have to, when you are going for high strength concrete, you have to go for advanced admixtures like not just super plasticizers. So you have to go for high performance super plasticizers, right? Not just the super plasticizers. So basically, you are reducing the amount of water, and sand and aggregate contents can remain similar. You might have little bit of cement more, and sometimes you will not need even that. You might actually replace some of the cement by fly ash. When you are going for high strength concrete, you have to be a little careful because if you try to get high strength by just increasing the cement content, then you can run into various problems like cracking and all that. But on the other hand, you are going to say, although I want 70 megapascal concrete, at the end of 28 days, I need only 50 megapascal. And as the building is constructed, I have no objection, concrete gaining more strength and going up to 70 megapascal. So you might have that type of situation. So what you understand is, those days, early days, we used to say, oh, Sri Lanka. So when the British court recommends minimum like 30 megapascal for cube strength, we used to say, oh, we'll use only 25 megapascal in Sri Lanka because Sri Lanka has warm conditions and we used to say, okay, our exposure conditions are not as severe as other countries in the Europe. But what we have forgotten is Sri Lanka is surrounded by an ocean, and oceans contain chloride ions, and then if you get chloride ion contamination, our exposure conditions can be much more severe than what is anticipated in courts. So because of that reason, a time has come for us to change our mindset and say, okay, we have no fear of going for high strength concrete, but the consultants have to be very flexible. The consultant should understand. It's very unreasonable to say, tell the contractor, achieve something more than 50 megapascal in 28 days. It's not possible. But in your designs, what you do is you make use of fly ash, which can give a long-term reaction, so that you are specifying high strength, but not on the basis of 28 days strength. You might say, after 1 year, I like to see cement. But at the end of 20 days, it is enough. So that type of mindset change is needed from the consultants. Otherwise, consultants insist on things that are very hard to be delivered by the contractors. And the poor contractors then go to the university, they ask for some advice, they come up with various solutions. Those are not necessary. If you are a consultant, please understand, getting anything more than 50 megapascal is very difficult at site conditions within 28 days. But the moment you include fly ash in the concrete, the reactions will continue. They will not stop at the age of 28 days or so. The reactions will continue forever. So you are going to get a strong and strong and strong concrete. And also, in addition to that, when you go with fly ash, significant amount of fly ash, like 20-25%, the chances of chloride attacks would be very remote. So basically, what you have to see is, time has come for us to break away from the traditional mindset of using low strength concrete in Sri Lanka, because we also find our ingredients with great difficulty. So why not go for stronger buildings that are going to last forever, or that are going to last a long period of time, not like 50, 60, 100 years. The buildings will last something like 200 to 300 or 400 years, because once you use high strength materials, if you are doing routine maintenance and if you are doing routine inspection, you can very easily detect any problematic places, and then you can attend to the repairs of those maintenance work, and then keep the building in a good shape. Then you are assured of a building that can last a very long period of time. So basically, you have to always think positively. But early days, we used to think negative. The reason for negative thinking is we always thought we can't get it done. But these days, I'm going to make a trial where I'm going to do wave etching at the site, but use an admixture and get something like 30 megapascal in 28 days. And I'll use fly ash also. I will allow them to rise to about 40 megapascal. So there are so many tricks that the consultant can play. So don't be confined by what you have learned at the university. Always see how best I can support the contractor to do a quality job by specifying things that are realistically achievable. So that's the way you have to look at it. So basically, you can see it asks for the E value of the material. So I will say E value is for 25 megapascal concrete 25, 27 megapascal concrete around, sorry, 30 megapascal concrete is about 27, 40 megapascal concrete can go up to about 31 kilonewtons per meter square. So 31 e to the power 6, 31 e to the power 6. And then weight of the material, so you can say it's 25, and you can say 2.5. And then concrete strength 40 megapascal, 40,000. And thermal expansion coefficient, you don't have to rock the ship too much. You can keep it as it is. And then, you can say normal weight concrete and say, okay. Okay. So we have concrete 40. Similarly, we can define so many other concretes. And so basically, we go for when you define. I generally define slightly differently and a copy of the material. So I'll have something called column concrete 40. And I'll also have beam concrete 40. So I'll have two things, column concrete 40 and beam concrete 40. You ask why? Let's say when we look at the model, we find some places where the column may have some restrictions on the size, so you might consider going for a different grade of concrete or higher grade of concrete. So for columns and beams, I prefer to define two separate concrete types. So then what we have to do is we have two materials and we have to define the sections as well. This unfortunately, its program is not responding. There's a small problem. I'm trying to get this SAP working. SAP got stuck. So I will. On the chat box, one person has asked, what is the strength of the steel to be used, and whether it's 460 or 500. So basically, now if you look at most of the manufacturers in Sri Lanka are capable of making QST bars, conch and self-tempered bars. So basically, you can use 500. No harm in using 500 these days. Only thing is you have to specify it. Hot roll bars or QST bars, not the normal toe steel that was twisted. So basically, the twisted bars would have a strength of 460, whereas the QST bars will have a strength of 500. And even the British code allowed use of 500 later. So our country, we have moved towards 500. So we have plenty of factories that are making 500 type steel. So you can base the designs on 500 newtons per millimeter. So I'll try again. Trima, can you see the screen now? Okay, we got this defined. Now I can design the frame sections. And so frame sections add a copy. So we say a new property. And here, can you see this screen, Trima?
So we can see the
And we
screen.
go for concrete section. You can see the screen. And then we have to say column 1000 by 1000. So give the size of the window. Just say, don't say column 1, column 2, column 3. It's very hard to see what's going on when you make a big model. So always give the column size as 1 and 1. So let's say okay. And you can also work it to column concrete. Similarly, we'll have add a copy of the property. And we'll say beams are 600 by 400. And here we'll put the beam concrete. Size of the beam is 0.6 meters of depth. And 0.4 meters of. So basically, we have to define another material, other one, that is we are going to have shells. We are going to have shells, shell elements, and a new section. Because we are going to have shear walls. So we have to have wall. I'll use 250. I need a new concrete, so I'll say it's column concrete 30, but you can define wall concrete 40 as well, wall concrete 40 as well. I think it asks for the thicknesses. So you have to give two thicknesses. You'll ask why. The reason is the membrane is used to calculate the weight. And for flexural behavior, it will get the thickness from the bending parameter. So basically, you need to have both for the steps. And then we say, okay, I'll show how we can manipulate set modifiers later. And then we also need another concrete, because we are going to draw the slab panels. For that, we need to have another section, and that is again the slab says say 175 whatever thickness. Point 175, and here also we say okay. Our section name is slab 175. But here we have a problem. I just use this column concrete 40. We say okay, but we later fix this problem. Now, if you look at the weight, we are going to give the weight manually. So anything you is here to show that it all behaves as 1 unit or instead cast is by modeling the slabs also. But when you're modeling the slabs, if you use normal concrete for the slab, then you will be double count. Because when you are looking at dead load, I showed you, we include the self weight of the stuff. So if you put another self weight, then you are double. So I say okay, and because of that reason, we have to define under the materials a new material. The copy of the material. So the new material is slab concrete. So slab concrete. And what we do is here we don't want the weight. So we say the weight is 0 weight per unit volume. We are going to say weight is very small. And then mass, we'll see how to modify it later. We'll not worry about the mass now. So basically what you have to see is always be mindful that when you are doing the design, always check. Okay, I'll say I'll change it. Slab concrete 40. But slab concrete 40, the special feature is it has no weight. What is the reason? Here we have a slab, I'm going to say it consists of unit slab, and then the weight of the slab will be transferred onto all these beams. But what will happen if you just create a slab here? Select slab. It crashed again. But it's coming closer to 8:25. Shall we continue next week onwards? Rima?
Yes, sir.
Rima? Yeah.
Yes, sir. Yes.
Yeah, there's another question coming up. At the intersection of primary and secondary beam, do we need to model the secondary beam as simply supported beam? Yes, it should be simply supported. If so, what should be the top rebar of the secondary beam at the intersection? Top rebar can be two numbers of 12 millimeter bars. Two numbers of 12 millimeter bars. There is a. Can you show how to put reinforcement in cantilever slab and cantilever beam? I think we'll discuss it later. What is the thickness limit to define thin? Okay, so basically, if you are designing a pile cap or a transfer flow, then define it as a thick slab. But even otherwise, if you use a thick slab, if you define it as thick slab, there's no harm, because the moment you say thick slab, the shear deformations also will be taken into account seriously. A thick slab means the shear deformations are taken into account seriously. So if you want, you can just put it as thick slab wall. But the difference between thin slab and thick slab in the situations we are analyzing here, with most of the slabs to be thin, is is negligible. But on the other hand, if you are modeling a transfer beam or a transfer plate, then better to consider it as a thick slab. And then there should be best of category solid blocks because loads on slabs, additional reinforcement slab. Oh, there's a long question. Solid brickwork walls are to be supported on slabs if there are manual method to calculate. No, what you can actually do is, if you have some blockwork wall or a brickwork wall, go for a finite element model, and then you can release some of the support conditions to a certain extent so that you get a higher bending moment in the spans, and then apply this weight of the wall as a unit, as a line load, analyze it, then you can get the effect of that particular slab on the effect of that particular wall on the slabs. And you can easily find how much the bending moments are changing and so on. So when you are designing, you'll add those bending moments to the design so that automatically the weight of partition walls are taken into account. So the basic method is, if you have a thick, if you have a heavy brick wall or a block wall, then you can do a analysis. But when you are analyzing the slabs, you have to say, you have to go to set modifiers and say the moment carrying capacity is reduced by up to about 30%. You don't have the full moment carrying capacity because most of these slabs are cracked. And cracked slabs cannot be as strong as solid slabs. So basically, you have to make sure that if you don't want to put it on the model, then if you want to put it on the slab, you can do so. But the results can be slightly overestimates. But when you get a number, you can easily see which type of number that you need to have as the additional moment carrying capacity. So basically, you don't have to put everything that you have onto the model. You can decide what goes onto the model and what will not be used in the model. And then it says manual method calculation, 2D slabs, 1D slabs, one-way slabs or two-way slabs. Would be better of a cater for solid slabs. So basically, I don't like brick walls on slabs. If I am having a brick wall on a slab, and say, let's say we have a symmetrical situation, we have a slab on the other side also, sorry, slab on the other side, and also a wall is built similarly, then what I do is I'll put a concrete beam under the partitions and allow it to, transfer the, loads rather than using the slab. Now, why I do not like to use the slab if the loads are pretty heavy? Now, when you are doing calculations, all our calculations are based on the fact that the live loads are variable, dead loads are there. So basically, the situation is slab is not loaded full. Slab is very lightly loaded. But if you start keeping heavy loads on the slab as permanent loads, then what happens is, the neutral axis can increase, and that can give rise to some kind of a zone in the slab which is actually incompressible. And when certain portion of the slab goes into compression, it can shorten and can give rise to higher deflections in that water. So I prefer not to put a lot of loads on the slabs. And if I have to put a lot of loads on the slab, I will try to use a simple beam system, either below the slab or above the slab, so that most of the loads due to a partition wall will be transferred directly onto the beams rather than transferring it to the slab and then getting the beam to transfer it to the main or secondary beams. So basically, the idea is, you have to think what is logical, and what you have to see is all these deflection criteria, everything has been developed considering that most of the loads will be variable. But if you are going to have a lot of permanent loads, then you have to have slightly higher factor of safety, because there can be deformations that are associated with that. So basically, just be careful and always work out the system you are going to model. So if you are using ETABS, the data file can be very different to SAP 2000. So basically, when you are modeling on a piece of paper, as I have done, work out the details and then go for data. Otherwise, what happens is, when you start the model without having the data with you, that means you have not thought about the modeling. There are chances of getting the wrong model is also very high. So basically, always be careful, always be careful, and also work out the details of the model before you start the computer. The thinking part has to be done without the computer, because when you have the computer and start thinking, then sometimes you might try various shortcuts without thinking and make mistakes. So let's work out the model carefully and then start the program. So if a fire rating of lightweight blocks similar to normal sim blocks and are they sufficiently soundproof? Yes, all the lightweight materials have better soundproof properties than the normal weight materials. And what are the design concepts for three-story multi-story buildings and three-story buildings? So basically, the three-story building will not be subjected to heavy wind loads. So if you are interested in a three-story house type situation, unless it's a very exposed location, so basically the wind loads will not be governed. On the other hand, if it is at taller buildings, say 5 stories, 7 stories, 8 stories, 10 stories, then you will find wheel loads are significant, but because you have a lift, again, you don't have to worry too much about the vertical lateral loads. So there isn't a big difference between the design of a 3-story building and a 5-story, 10-story building. But because 3-story building may be associated with houses and so on, you might find the design is a little more complicated than the design of a 10-story building, which will mainly be used as a commercial building, unless you are designing an apartment building, right? So basically, so the message is okay. And thus we have to define the and this is no need actually, SAP will assume some reinforcement, but the chances of the reinforcement that SAP has assumed making an error is very remote. So because of that reason, no need to worry too much about reinforcement. No need to worry too much about reinforcement because SAP will anyway allocate a bit of reinforcement. So I think I have answered most of the 4 questions. Primary. So with that, shall we end the lecture, Shrima? Because I'll continue the modeling part next Tuesday also. Because today I spent some time showing you how you organize the data before you start modeling, right? And then once you organize your data and talk with the contractor, see what they are capable of achieving. If you have already selected the contractor, if you don't know about the contractors, but you might have some idea about the type of contractors you are going to get. Just talk to a few of them and see whether they are comfortable with the kind of strengths that you are using. But anyway, whatever the contractors say, they might always say, I like lower, but don't listen to them that way. Tell them that, the codes are advanced. They allow us to go for high strength. We want to go for high strength. The reason is, with the same amount of concrete, we can get a higher strength. Because the strength difference comes mainly from the water content than the cement content. So with that, I'll end it, Prima.
Yes, sir. Sir, I will invite Mr. Karthikeyan Turiraja to deliver the vote of thanks today. Karthikeyan, yes.
Thank you. Very good evening, everyone. It is such an honor for me to get the opportunity to express vote of thanks on behalf of Civil Engineering Sectional Committee of IESL. I would like to express my gratitude to Professor M.T.R. Jayasinghe for his presence and contribution to make this webinar series successful and to take out time from his busy schedule to grace this series. Thank you for inspiring and encouraging us with your knowledge and words, sir, all through. Special thanks to Engineer Mrs. Kamala Gunavarthana, Chair of Knowledge Sharing Subcommittee, Civil Engineering Sectional Committee of IESL, for providing this opportunity to deliver vote of thanks and tirelessly organizing this kind of lecture series. I extend my gratitude to Engineer Manjula Samarasinghe, Secretary of Civil Engineering Sectional Committee, and all other executives of IESL to organize this kind of great activities, even among their busy work schedules. I specifically thank IESL technical team, social media team, and all other members who worked hard to make this event a success. I want to extend my generous thanks to you all for your participation and cooperation. I pray you have a good rest and tomorrow may bring you much happiness. Good night. Thank you.
Thank you,
Thank you, Karthikeyan. Thank you. So we will wind up, sir, today. So we'll
Shall
meet
I
once again.
leave?
Yes, sir. Right. Thank you very much.
Okay,
Good
thank
night,
you very
everybody.
much.
Good night, everybody.